Okay, now we have to continue to check the answer for question 2. For question 2, is an enthalpy question. It's basically finding the reaction change when an anhydrous salt is turned to hydrated one. Can you see that? Anhydrous to hydrated one. But of course, we know that in laboratory, it is impossible for us to do this experiment because you cannot measure the enthalpy change by inserting 10 water molecules into an ionic compound to form the anhydrous salt in a hydrated one. However, we learned Hess's law, right? So that's why we can do it. The idea of this exam question is you have anhydrous one, right? And you want to measure after putting 10 water molecules into it. What will be the change of the enthalpy change of reaction? It's impossible for us to do this in the laboratory. However, we can do another experiment that is easier. That is, we dissolve the anhydrous salt and hydrated salt respectively into large amount of water and measure the enthalpy change. Now, for sodium carbonate and anhydrous one, you add large amount of water, it will become sodium ion plus carbonate ion. Agree? And you can do the same for the hydrated salt, and it will come up with the same mobile ions. For this 10 water, you can ignore it because basically we are talking about infinity amount of water. So the 10 water molecules doesn't mean anything. So from here, you will get the solution of the anhydrous salt. And from here, you will get the solution, enthalpy change of solution of the hydrated one. Okay, then you with this enthalpy cycle, you can find out delta HR. Okay, by Hess's law. Okay, now let's look at the question. Now for part A, the question is trying to guide you to find out this value. For part A, the question is trying to guide you to find out this value. You have 50 grams of distilled water, and you try to put this mass of anhydrous salt, sodium carbonate, into this distilled water, and you find out the temperature increases. So basically what we are doing is we try to calculate that. Can you see the temperature increases from 27 to 32.4? So basically what we're doing is we try to work out the total energy absorbed by the distilled water, because the energy absorbed is actually the energy released by the sodium carbonate when it dissolves in water, right? So, okay, let's just do it together. First, delta E equals to mc delta T, right? So the M should be the water because water is the substance to absorb the heat. So 50, C is given here. Here. Okay, so the M is 50, 4.1A, and T is final minus initial, right? So it will be 1128.6 gram a joule, okay? And you divide it to 1,000 to turn it to kJ. So this will be the total amount of heat absorbed by the water, which is also equal to the total amount of heat released from 5.09 gram of sodium carbonate when it dissolves in 50 gram of distilled water, right? 好，now then we can also work out the MR of sodium carbonate first. That will be okay. And then you can also work out the number of mole of sodium carbonate and anhydrous one. That is mass over molar mass, right? The mass is here. 5.0. Where are the things? What happened? Thanks God. Okay, so it will be the number of mole. Wait, let me. Computer is such an idiot. Okay, let's continue. Very angry. Okay, and then the number of mole of sodium carbonate will be the mass 5.09 divided by the molar mass. Okay, so you will get 0.04802. Now, what's going on right now is when you dissolve this number of mole of sodium carbonate in 50 ml of water, this amount of energy is released. Then what will be the amount of energy released when 1 mole of sodium carbonate is dissolved in water? Okay, so that is actually the solution of the anhydrous salt, okay, which will be equal to the energy divided by the mole of sodium carbonate. Remember, do not miss the negative sign because as I told you, temperature increases, so it's exothermic, right? Then what we are doing is negative this number divided by this number. Then you will find out the amount of heat released when 1 mole of sodium carbonate dissolved in water. Then if you do it correctly, it will be negative 23. Okay, so you will get this number. Okay, part B. Part B is exactly what I told you. Okay, part B here. So basically, I can do this. What happened? Hey. You're okay with part A, right? So you just use E equals to MC delta T to work out the amount of heat released, okay, when 5.09 gram of sodium carbonate dissolves in 50 gram of water. Then by dividing the energy by the number of more sodium carbonate, you can work out the enthalpy change of solution of anhydrous salt sodium carbonate. This is exactly what I just told you before I explained this question. So it will be aqueous and aqueous, then you will get the mobile aqueous ion, right? So now from now you have to find out this, okay? This enthalpy change. From part A, from the previous part, you already got this number. That is negative 23.503 kJ. And this one is given, that is positive 53.7. Now how can you put them together to find out delta HR? That is easy, right? If you look at the arrow, this one will be equal to this one. So you will put them together, delta HR plus 53.7 equals to negative 23.503. So the delta HR will be negative 77.203 kJ per mole. Okay, so do you understand what I'm saying? The idea is that it's impossible for us to do this experiment in the laboratory, but it is easy for us to do this and do this, okay? And this is your part 1. And this one is given, so you can put them together with Hess's law, then you can work out these delta HR, okay? Oh, last part. Hydrated sodium carbonate slowly loses some water crystallization when left in air. Explain how the enthalpy change of the second experiment would compare. Okay, now, think about what will be happening is, if you refer to part A, okay, basically the enthalpy change of solution of, right now you're talking about the hydrated, right? Hydrated salt is equal to the energy absorbed by water over the number of mole, right? Over the number of mole. Now imagine how do you work out this mole? This mole is basically the mass over molar mass. Do you agree? Imagine if some of the water is lost. So what happened to the actual molar mass? What happened to the actual molar mass? The actual molar mass will be smaller than the one that you use in the calculation. Do you agree? The actual one, which means your MR is actually bigger than your MR you use in the calculation because you consider it as 10 water when you work out the molar mass, right? But in reality, it is less than 10 because some of them is lost. So the MR you use in the calculation is bigger than the actual one. So take a look here. The mass is a constant, but you are you over the mass with a bigger number, then the mole will decrease. Do you agree? If the mole decrease, if the denominator decreases, the whole number will go up, okay? So the enthalpy change of solution of sodium carbonate, the hydrated salt, will be more positive. I repeat once again, it's abstract. Now, when you are doing this, right, the mole is from mass over molar mass. Mass is a constant because you get it from the balance, right? But the molar mass, during your calculation, you will just sum all the atoms together and you still consider there are 10 water molecules. However, as what the question is saying, it is no longer 10. It is less than 10 because some of the water crystallization is lost. So the actual MR is actually less than the MR you use for calculation. So this MR is bigger than actual one. If you over the mass with a bigger number, the mole you obtain will be less than actual. If the mole obtain less than actual, and it is the denominator, the whole number will go up. Okay? Then the enthalpy change of solution of hydrated sodium carbonate, okay, will be higher than actual. Okay? Try to think about it.